A3, graphing reciprocal functions. Now, the first step of graphing reciprocal functions is we gotta talk about what a vertical and horizontal asymptotes are. Now, we talked about them informally in the past couple lessons, but now we're gonna actually talk about them. We'll give actual formal definition of these two. So first, a vertical asymptote. So these correspond to the restrictions on your domain. So what these are vertical lines you cannot cross. Right? Again, these are just like your restrictions. On the domain. So how do we find these? Well, it's like the restrictions. You set the domain equal to 0. So that's what these are. Vertical asymptotes are these vertical lines you cannot cross. You have a vertical asymptote right there. Your graph cannot cross. You have to turn up, turn down, because you cannot go past that vertical asymptote. So that's a vertical asymptote. Again, how do you find them? You set the domain equal to 0. So that's what vertical asymptotes are, right? Vertical lines you cannot cross. Horizontal asymptotes, on the other hand, you can cross. Horizontal asymptotes, these tell you about end behavior. So these tell you about the end behavior graph. Of your graph. Now, very important about this, you can cross these. So these you can cross. A lot of times you touch them when you cross them, that's fine. These just tell you what happens at the end. So let's do an example real quick. Let's say I have a horizontal asymptote at y equals 3. So go 1, 2, 3. All this graph, all the horizontal tells me is what goes on at the endpoint here. At the end, I should be getting close to that line. So if I have a graph and I go like this, like, oh, there's a horizontal asymptote. I should be getting close to that as my graph goes on. Same thing on this side. I could go up, I could cross this, but as I get closer to the asymptote, I should be getting close to this asymptote. As I get close to the left end here, I should be getting close to that horizontal asymptote there. That's what horizontal asymptote tells you. It lets you know what's going on at the endpoints. Vertical line you cannot cross, right? Cannot cross. It lets you know, oh, that's an area of the graph you don't have a value on. Horizontal asymptote just tells you how the ends go. That's it. How do you find these? Well, it's all about the powers. And for now, the only one we have to worry about is this. If the bottom power is bigger than the top power, it's at y equals 0. Plus any vertical shift. So by our default for now, it's just y equals 0. Our asymptote's going to be at y equals 0. So let's talk about basic. So that with that idea in mind, let's talk about a basic reciprocal graph. That's this one. So a basic reciprocal function looks like this. 1 over x. And as always, let's make a table. Right, x, y. Let's make it a little different. Let's do -2, -1, -1/2, so you can see what that does. And then we'll do opposite. We'll do 1/2, 1 and 2. Now remember, this is a reciprocal function, so look at if I plug in, I get 1 over -2. So let's have a graph here. -2 and -1/2. So look up here. -1, plug in -1, I get -1 over 1, or just -1. So like that. -1/2, this is why I did this, because I got 1 over -1/2. What that does is flips to the top, -2. 0, I get 1 over 0. Remember, you cannot divide by 0, so that does not exist. That's our vertical asymptote at 0. You can divide by 0. I have an asymptote there. Now, plug in 1/2, so 1 over 1/2. I just get +2. Plug in 1, I get 1 over 1, or just 1. That's 1/2, so this is 1. My graph's okay. Plug in 2, I get 1/2. So as I get bigger, it's going to get smaller. I plug in 2. So if you look at my graph here, it's kind of like this. That should be going closer this way, but the thing sucks. Right, you want to kind of hug the edges here. So into effect. Or perfectly, something like this. Right, but that's where it comes from. That's a reciprocal function. So now we add this to our ever-growing list of functions. Now we know if my graph looks like this, the graph should look like this. And once you get that, it's all the same thing. We're going to move up, down, left, right, blah, 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 blah. Right? But that's what a basic reciprocal graph looks like. So first, let's talk about let's find our domain and stuff. Limitations of the domain. So this is the same thing as our vertical asymptotes, because they're the exact same as limitation of the domain. So how we're going to find this? We're going to set the denominator equal to 0. So that's how we're going to find these limitations to our domain. These are based on these are just the vertical asymptotes. So here, right, so let's find our vertical asymptote. I'm going to set the denominator equal to 0. So x minus 1 equals 0. X equals 1 is my limitation, my domain. Right, we can't divide by 0, so let's make the denominator 0. So at x, when x is 1, then my denominator is 0, and that's also my vertical asymptote. So for a graph, right here would have a vertical asymptote at 1. That's the idea. Over here, same idea, right? Let's find out where the vertical asymptote is, so the denominator equal to 0, because you can't divide by 0. And you can solve it. And there's the limitation of my domain, or also known as the vertical asymptote. X equals negative 2/3. Right, so that's the one number I can't plug in here, because I'll get a 0 denominator. If I graph it, I get a line like this. Now let's look at those properties based on a graph. So in this question, we want to find asymptotes, right? So we have two. We have a horizontal one at y equals whatever. We have a vertical one. We want to find the domain and the range. So let's talk about the vertical asymptote first. Now they do have a graph here, and we'll talk about that. But let's look at the graph. What's the line that like these both can't cross? It looks like there's a line right here. Right now, I shouldn't be touching that, but it looks like around x equals 3. It's my vertical asymptote, right? So there's a line right here that they both graphs are shining away from, and that holds right here with the graph. Remember what we just talked about? You set the denominator equal to 0. You get x minus 3 equals 0. You get x equals 3. That's your vertical asymptote. That's how you find it. How about the horizontal asymptote? Remember, this tells you what happens at the endpoints. So it's the y equals line. Look at your graph here. What's the line horizontally that they're both kind of like hovering around? That's this line right here. If I could draw a straight line. Right, this is looks like y equals negative 2. And how do we get that based on the equation here? Well, remember what I said earlier? It's by default it's y equals 0, but if it's the vertical stretch right here, then it's that. So it's y equals 0 plus the vertical stretch. In this case, y equals negative 2. Right, it would be 0, but then you move the whole graph down 2. So it's at y equals negative 2. And then let's take a look at the domain and range, right? As always, nothing ever changes. Domain is x. Let's look at the graph, right? From farthest left, I go negative infinity because of arrow. And then I hit the wall right here, the vertical asymptote. So I negative infinity, and I got to stop at 3. So I can't go past that line. Then I start again at 3, and I go all the way to infinity. So 3 to infinity. And the way we connect those two is we put a little union sign. So we're saying this plus that. Similar for the range, low to high. The lowest I see right here, negative infinity. Then I got to stop right here at the asymptote. That my graph isn't going to read past that. So negative infinity to negative 2. Union, we start again at the asymptote because of this graph right there. Up into infinity. That's the domain range of that one. Let's do another one real quick now that we understand it. Right, so on this one, let's do the vertical asymptote real quick. So again, there's two ways to do it. If you have the graph, you just look at this, set it equal to 0. So x plus 2 equals 0 because you can't divide by 0. That's meant equals 0. So you solve it, x equals negative 2. That makes sense in this context, right? Negative 2 is a line that they're both kind of hovering around. If I want the horizontal asymptote, by default in this problem, it's 0. We'll talk more about it why later, but it's 0, but then we have a vertical shift of 1. So it's actually going to be at 1. Normally it's at 0, but now it's going to be at 1 because we move the whole graph up 1. Just like that. Domain and range. Domain is the x values, farthest left. negative infinity to looks like about 0. Or negative 2, sorry, I couldn't see. Union, you start again at negative 2. And go all the way to infinity. Right, your domains is broken up by that one number you can't be. Same thing for the range. Low, negative infinity. Highest I go, looks right here at 1. Union, 1 to infinity. Now that we have all the basics, let's talk about how to graph this stuff. Just like always, right? Once we get the basics, now all we're doing is to move it, right? A basic graph looks like this. That basic graph is our reciprocal function. And then as always, anything on the inside, that's considered the inside, moves left and right. Anything on the outside, moves it up and down. The outside is also a vertical asymptote, a horizontal asymptote. It's at y equals k. Our vertical asymptote is when the denominator equals 0. Other than that, it's like normal. Same thing, what if I give you similar to what we've been doing before, what if I give you a negative a over x? Right, it's on the outside, it's a vertical flip. So normally your graph looks like this. You're going to flip it vertically. So down is up is down. Kind of like that. It's not the best picture, but that's the idea. Right, you flip the whole, this is a normal one. Right, but if it's a negative, you flip it upside down. Other than that, it's all the same rules we normally apply. So let's do a few examples and then we're done. So let's look at this one. Domain graph and say domain range. So the way I like to do this is I like to find the asymptotes first. So let's look at the vertical asymptote and the horizontal asymptote. Remember vertically says the denominator equals 0? Well, there's nothing there, so x equals 0. That was easy. There. Horizontal, remember it's all about the powers. In this case, it's always 0 unless there's a vertical shift. There's no vertical shift here, it says a plus 0. So that's also at 0. So I get that. And I have 5x. What 5 does is like your a, it's your vertical stretch. So 5 should be a little further out than normal. But remember, we're doing a sketch. I just want a sketch of this. So it looks something to this effect. We're just sketching it. So that's what it looks like. Because again, that 5 is kind of how far out you should be from the center. And actually, let's look at Desmos. All right, let's go to my Google. Let's go Desmos calculator. All right, click it. So this will show you, right? Let's go y equals 5 over x divided by, there you go, x. Right, if you see it, right, you kind of, so that's what a 5 over x is, kind of what we got. Let's compare that to y equals this 1 over x. Right, see, a lot closer in. Actually, a distance starts kind of a distance at 1. Now, 5 doesn't start a distance 5 away, so you gotta watch it. Right, but again, we're just doing a curve. But that's the difference, right? The bigger the a, the further out you get from the center. So if I give you one, let's change this one to, let's do another one actually. Y equals 10 over x. It's gonna be further out, right? It constantly goes. Like I said earlier, what if I make this a negative? Oops, wrong way. The same negative 10. Right, then it flips it upside down. Right, so that's the way it goes. Again, we're just doing a sketch, so I just want you, as long as you understand positive, negative, we're good. But the bigger the a, the further out it should go. The one, it kind of hits out the one spot, and then the bigger, the further out you go. So let's talk about this one. Same, oh, I didn't do domain. Domain, right, so again, so I'll kind of cut it by right here. So it goes negative infinity and until 0, because I can't do anything. Union 0 to infinity. And again, domain is always going to be cut by the vertical asymptote. Because vertical asymptote is x equals. You're always going to be broken up by that. And likewise, the range is the y. So it gets broken up by the horizontal asymptote. Negative infinity to 0. Union 0 to infinity. Okay, now let's talk about this one. Alright, so we have this. As always, I think it's easier to find the vertical horizontal asymptote. Easiest thing to do. So remember, vertically, you set the denominator equal to 0. So x plus 3 equals 0. So x equals negative 3, right? That's like my restriction to domain. The one number I can't be is negative 3, so that makes that my vertical asymptote. So at negative 3 on my x, draw a little vertical asymptote. Let's find the horizontal asymptote. By default, it's y equals 0 plus the vertical shift. There's none here, so it's just y equals 0. Notice it's a positive 2a, so it's going to be a little further than normal, but for most part, it's simply positive like this. And that's my graph. Domain and range real quick. Where domain is x. Again, it should be cut up by this thing, so that lets you know where you broke up your domain at. Because you go from negative infinity to negative 3. Union 3 to infinity. Negative 3 to infinity, sorry. And then range is broken up by the horizontal, so you can tell because it says a y in it. So negative infinity to 0. Union 0 to infinity. And that's how you graph those. Let's get a little more complicated. Let's look at this next one. Again, let's find the vertical asymptote first. Set the denominator equal to 0. So x equals 1. That's my vertical asymptote. Right, the one number you can be. So x is 1. Horizontal asymptote, we actually have something this time, right? Default to y equals 0. But I do have a vertical shift this time. So plus 2. So it makes it y equals 2 is my horizontal asymptote. Remember, you can cross the horizontal asymptote. We're not going to do it in this case, but you can. Horizontal asymptote is all about the endpoint. So your graph should be getting here and here at the end. Next up, it's a positive 6. So again, we should be a little further out than normal, but again, this is a sketch. As long as you know it's going to be like something to this effect. That was kind of terrible, honestly. Same idea here. Let's go. Oof. Don't try this at home, kids. So like something to that effect. Ouch. But that's the idea. Domain, right? X values. Again, it should be broken up by the vertical because the x right there. So we look at it, negative infinity to 1. No one touches anything at 1, and then 1 to infinity. Range, likewise, is broken up by the y value, the horizontal, negative infinity to 2. Union 2 to infinity. Next one up. Right, here we go, vertical asymptote. Set the denominator equal to 0. So x equals 7. Vertical asymptote. Horizontal asymptote. Right, default for now is y equals 0. We'll talk about more about next time. Unless there's a vertical shift, so you have to add that vertical shift. So plus negative 8, or just y equals negative 8. That's my horizontal asymptote. So if I graph it, just go to negative 8. Shortcut. And then your x equals 7. So here's 7. Let me scroll down a little bit. A little more advanced to this graph. Now in this case though, if you notice, right there it's a negative 6. So it's going to be a vertical flip. So normally it looks like something to this effect, top right, bottom left. It's a negative sign, so it's going to be on the bottom left. Bottom right, to say, and the top left. So we flipped and over to normal. So it's that effect. Domain, negative infinity to 7, 7 to infinity. Range, negative infinity to negative 8, negative 8 on. Few more. We're almost done. Should do this a little faster. This one real quick, right? Vertical asymptote. Keep in mind, right? Oh, can't divide by 0. That's all you do. So x equals 0. Done. Vertical asymptote. Horizontal asymptote. It's this thing, right? It's y equals 0 by default, but then you add in the vertical shift, so y equals negative 5. So if I was graphing this, 1, 2, 3, 4, 5. And then x equals 0. It's a positive 6. You can kind of see if I didn't draw that. So it's a little more out than normal, but still kind of going to hug it kind of this way. And then down here. Oh, not my best graph. Domain, right? Negative infinity to 0. 0 to infinity. Range. Domain is basically everything that's not 0. And your range is everything that's not that. It's a little shortcut if you want to do that. But right, negative infinity to negative 5 to infinity. One more. Graphing. Yeah, I'm a little tired of graphing too, I know. Vertical asymptote. So the number equals 0. X plus 7 equals 0, right? Again, the whole point is, what could he not be? That's what vertical asymptote's all about. So you solve it to get negative 7. Horizontal asymptote, right? Hopefully it's easy. Like, you're so bored because it's so easy. It's y equals 0 by default, but then we're going to subtract 1 because we're going down. So y equals negative 1 is my horizontal asymptote. Graph those things first. Negative 1, blah, 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 blah. Negative 7, 1, 2, negative 7 over here somewhere. Right, and again, notice we have a negative a on top, so it's going to flip. So instead of being up here, it's actually going to be down here. And on this side. So there you go. If you're not sure, you can always make a table. Remember, that always works by default. Since my last one, domain. Right, let's do that. Remember, it's always broken up by the x here. That's what it's for. So negative infinity, and then you have to stop here. Negative 7. Union, negative 7 to infinity. Or as I said last time, everything but 7. Range is broken up by the y, because range is the y values. So negative infinity to negative 1. Negative 1 to infinity. And that's how you graph. Okay, let's do one last application problem. Last thing we're doing in this video. So a group of friends plans to get their youth group leader a gift certificate for a day at a spa. Certificate costs $150. If C represents the cost of each friend and F represents the total number of friends, right? And the equation to represent the cost of each friend. So here's a general idea of these things for A. Right? So cost of each friend, so C equals, well, it costs $150 total. And you just divide it by the number of friends you have, right? If you have 10 friends, it's 150 divided by 10. That's how we're going to do this. That's how much I pay. So that's your equation. Right? Cost is just going to go how many friends, the total cost divided by the number of friends we have. Then now they want me to graph the function. Well, graph it like we always do. What's the vertical asymptote? It's the bottom equal to 0. F equals 0. Horizontal asymptote. By default, y equals 0. There's no y here. So 0. So something to this effect. 150 is way further out than we're normally used to, so something to that effect. Again, it's a sketch. You get that? Explain any limitations to the range or domain of the situation. Yeah. Right? What are some limitations? Remember, we're talking about cost. So this is my x, or my f in this case. This is my cost, right? The more friends I have, the less it's going to cost each one. If we have 30 friends, it's going to cost us like each a little bit. If I have no friends, me in high school, then it's going to cost me a lot. One friend, 150 divided by 1. Ouch. Ouch. I don't know what ouch is, by the way. I have no idea. But does it make sense? This stuff, you can't have negative friends, even if you're not popular. That makes no sense. And you can't have negative costs. They're not going to pay you to take the spa day. So none of these make sense. Only positive values. Or the only part of the domain that makes sense are 0 to infinity. And the same thing for the range. So that's it. There we go. Until next time.